Okay. Ooh, dang it. I really thought, but I didn't. Okay, whatever. All right. We are back. Okay? We're back. We're having fun, doing stuff. This is probably timed out. Yes, that's what I thought. So let me hide that browser real quick. Put in my super secret passcode. And let's bring it back. There we go. Okay. We're good. We're good. We're good. We're doing this stuff yet again, trying to do our absolute best. I believe we were on 5. Yes, we were. We were on 5. So, oh good, this isn't connected. Let's see if this is working. Sometimes it takes like a few hits.
An IT engineer digs through a closet to find a Wi-Fi router to use while waiting for a new one to arrive. The IT engineer chooses between several routers and selects one that supports both 2.4 and 5 GHz frequencies. Which 802.11 standard does the engineer use to support both frequencies that will connect common mobile devices?
N. G's legacy. A is 4.5 or 2.4 only. B is 5 only. It's got to be N. Let's go.
A tech replaces a failed wireless router at a company. While waiting for the new router to arrive, an older router is put in place and will only provide speeds of 54 Mbps. Which wireless standard does the older router use?
G. And I know that because this is Wi-Fi 5. I think that's 6. That's just 5G. Okay.
An engineer has installed a new router but is not connected to the core network yet. What type of connector should the engineer install to get the requested throughput of 30 Gbps or more?
I think we can stand to have the music a little bit louder. Maybe not too much louder, but I think right there is good. Okay, what was the question? An engineer has installed a new router but is not connected to the core network yet. What type of connector should the engineer install to get the requested throughput of 30 gigabytes or more? Okay, so he's got a router. It's not connected to the core network yet. Core being the key word there. Coarse wavelength division multiplexing. Dense wavelength division multiplexing. These I don't know what the name core means. I don't know what that means. I don't know if that's core, like the hierarchy of stuff. But that still doesn't lend itself to meaning fiber. That just means like router to server. That doesn't necessarily mean Man, that sunlight is fierce. We're gonna go with it. Okay, we'll come back and learn. Okay.
A network installer is building a long-distance link. Nodes are approximately 5 kilometers apart. What type of fiber link should the installer build for this link?
A newer version of Vice is available. Okay. Let's do it. Not Vice, Vince. Okay, so what I have a hard time with is connecting these to what they actually are and what they mean in terms of data transmission, like how much it can give and its length. So let's see what this has to say. Nothing. It has nothing to say. Oh, it's working.
Restate the question. A network installer needs to build a long-distance link between two nodes that are approximately 5 kilometers apart. What type of fiber link should the installer build for this link? Simplified answer, 1000 base LX. Analogy, think of 1000 base LX like a long-distance runner. Just as a long-distance runner is designed to cover longer distances, 1000% base LX is designed to support longer-distance fiber links, making it ideal for this scenario. In-depth explanation. 1000 base LX is a type of fiber optic Ethernet standard that supports distances of up to 5 kilometers, 3.1 miles over single-mode fiber. It operates at a wavelength of 1,310 nanometers and supports speeds of up to 1 gigabits per second. This makes it an ideal choice for building a long-distance link between two nodes that are approximately 5 kilometers apart. Why not 100 base SX? 100 base SX is a type of fiber optic Ethernet standard that supports distances of up to 550 meters, 1,804 feet, over multimode fiber. It is not suitable for longer distance links like this scenario. Why not 10G base senior? 10G base R is a type of fiber optic Ethernet standard that supports distances of up to 400 meters, 1,312 feet, over multimode fiber. While it supports higher speeds than 1000 base LX, it is not suitable for longer distance links like this scenario. Why not 100% base FX? 100% base FX is a type of fiber optic Ethernet.
Okay, let's do this. So we have single multimode, multimode fiber, OM1, multimode fiber, OM2, multimode fiber, 4 and 5. Plastic optical fiber. How does this correlate? I feel like correlate has 2 R's. Still feel like that's wrong. Oh, it's an E. Man. How does this correlate with things like 1000 base dash LX? Isn't that a cable 2? So there's different types of fiber, which I knew, but I didn't know that there's all these. So we have single mode and we have multi-mode, which is really what the Network Plus really does. Speeds up to 100 gigs. 99 miles. Jesus Christ. Core diameter. Okay. 100 gigs. Up to 2 kilometers. Distance up to 2 kilometers for 100 megs. Oh. 2 kilometers? That's slow. 100 megs? That's slow. 1 kilometer for 1 gig. And then 500 meters for 10 gig. Wow. So multi-mode is not good at all. It's used for short distances, communications, enterprise and data center networks, and application requiring high bandwidth. So it's because it's multi-mode, it's dealing with a lot of bandwidth, a lot of things that are going into stuff. Okay. ML1 or OM1 multi-mode, it's a multi-mode fiber, speeds up to 1 gig, distance 300 meters. It's pretty thick. Short distances. Short distances. Short distances. All this multi-mode is short distances. What about this? Speed up to 1 gig, 1 millimeter. Dang. Thought I was gonna sneeze. Note the distance listed above are approximate and can vary depending on the specific application and installation conditions. Okay, cool.
Ethernet standard that operates over single-mode fiber at a wavelength of 1,310 nanometers. It is capable of transmitting data at speeds of up to 1 Gbps over distances of up to 5 kilometers. How it correlates with fiber cables: 1000% base LX is a type of fiber optic Ethernet standard that uses single-mode fiber cables to transmit data. Single-mode fiber cables have a smaller core diameter than multi-mode fiber cables and are designed to transmit data over longer distances. Why it's not a cable? 1000% base LX is not a type of cable, but rather a standard for transmitting data over fiber optic cables.
Whoa. I didn't know that. So this is a standard. Fiber optic Ethernet standard. Give me an image. Buddy. No, what was the image that was right there? This. What is this image? Show me this image. Make it bigger. Wow. Fiber just blows my mind, dude. We're gonna read this.
At its most basic form, fiber optic cables are thin strands of extremely pure glass fibers. Each fiber also has an internal cladding that bounces light inward to prevent signal loss.
Whoa.
They transmit information using light from lasers or LEDs modulated with data. There are two major types of fiber optic cables: single-mode and multi-mode. Single-mode cable is used for long-distance network connections. It typically has a cable diameter of 9 microns, and just one wavelength of light can be transmitted. This minimizes attenuation due to decreased internal reflections. Multi-mode cable has a greater diameter running from 50 microns to 62.5 microns. It can handle several wavelengths of light and multiple signals at high speeds. It's used over shorter distances within a data...
Dang it. I gotta answer this. Hold on, that was a fraud alert. I think someone stole my credit card again. 1 second. Almost got it figured out. Give me one more second. Okay, I'm back. Let's go back to this.
Center or local area network, fiber optic speed and distance comparison. The charts below.
We don't need to read all these charts. So 1, 2, 3, 4, 5, 100 meg, 1 gig, 10 gig, 40 gig, 100 gig. I don't care how big it is. 33 meters, 82 meters, 300 meters, 150 meters, 550 meters, and then 500 meters. Okay. Custom. Okay, no. Let's, can we be done with this? I want to be done with this. So what we were just figuring out is that this LX is a type of fiber optic Ethernet standard.
%% base LX is a type of fiber optic Ethernet standard that uses single-mode fiber cables to transmit data. Single-mode fiber cables have a smaller core diameter than multi-mode fiber cables and are designed to transmit data over longer distances. Why it's not a cable? 1000% base LX is not a type of cable, but rather a standard for transmitting data over fiber optic cables. It defines the specifications for transmitting data at speeds of up to 1 Gbps over single-mode fiber cables. Types of fiber cables. There are several types of fiber cables, including single-mode fiber SMF cables. These cables have a smaller core diameter and are designed to transmit data over longer distances. Multi-mode fiber MMF cables. These cables have a larger core diameter and are designed to transmit data over shorter distances. OM1, OM2, OM3, and OM4 cables. These are types of multi-mode fiber cables that have different core diameters and are designed for different applications.
Okay, so speeds and distance of fiber cables vary depending on the type of cable and the standard used. Here are some common speeds and distances for different types of fiber cables. So this is a standard and it goes, okay. This is the part that I was needing to understand. So this is the standard. So therefore, since it goes up to 1 gigabyte over 550 meters, it is multi-mode. So does that mean, okay, so does that mean that 1000 base dash SX cannot and is not single mode fiber? If this is true, then it makes sense. If it's not, no. Okay, yes. All I needed was a yes, dude. Okay, hold on. So so this 1000, 10, 10, SX, LX, SR, and LR. I don't know what those things mean. Up to 1 gig, 1 gig. Now, okay. Now the 1000 base and then it meaning 1 gig, that makes sense. Because it's talking about 1,000 megs. And then it's saying 10 GB base or 10 Gs. That makes sense because it's 10 gigabytes. Okay.
(1,000 base SX, up to 1 Gbps
That is not what I did. I highlighted this, dang it.
over 550 meters,
Well, I tried.
multimode fiber.
Whoa, what is going on with my thing? Last chance. Okay, last chance. A company wants to connect two buildings that are 5 kilometers apart using a fiber optic cable. They choose a single mode fiber cable with a standard of 1,000 base LX, which allows them to transmit data at up to 1 gig for 5 kilometers. I'm starting to understand. What? Why are you not? Okay, hold on. I'll be right back. I just realized that there was no music playing while I had the I'll be right back going on. I apologize for that, but I am now back. I did not figure out why this won't read.
1,000 base SX is a type of fiber optic Ethernet standard that operates over multimode fiber, not single mode fiber.
I fixed it. You want to know why? Because I'm the greatest technician that's ever lived. Okay, I love that guy.
1000% base SX is designed to operate over multimode fiber, which has a larger core diameter than single mode fiber. Multimode fiber is typically used for shorter distances, such as within a building or campus, while single mode fiber is used for longer distances, such as between buildings or cities.
So LX has to be single mode fiber because it's so long. Okay, I'm an American, dude. Like, I have a hard time with the metric system. Like what? Okay, so what does SX, LX, SR, LR mean? And are there any others? What's happening? This type of fiber is small core diameter and is designed to transmit data over long distances. Okay, okay, that makes sense. Multimode fiber is a type of fiber, has a long core diameter, and is designed to transmit data over shorter distances. Okay, so core means the actual the diameter, the length, the size of the fiber. Nothing to do with the hierarchy of like the actual thing, of the actual topology. Okay. Let's see here. What do we got? What do we got?
The letters SX, LX, SNR, and LR are suffixes used to identify the type of fiber optic Ethernet standard. These suffixes indicate the type of fiber used, the wavelength of the signal, and the distance limitation of the standard. Here's what each suffix means.
Whoa, what? SX means short wavelength. So why is it an X? Why is it not a W? Why is it not an SW? So that means it's multi-fiber, multi-mode fiber, because it's short wavelength. Okay, LX means long wavelength, single mode fiber. Okay, and then this is the core. This is the core. Nanometers. Okay, this is making sense. SR means short reach multi-mode. Long reach single mode. What's the difference between the short reach and the short wavelength? They're same core, both are multi-mode. Is it up here? Short reach, short wavelength. Is SR just 10 gigabit? And is SH? Okay. Wavelength is the data per second, I think. So since it's short wavelength, that's only 1 gig over a short distance, 500 meters, which I believe is short. I might need to convert that into miles or feet or something. I have no reference for how long a meter is. Damn it. Okay. Curse you metric system. And then we have the SR, which is short range. So we are at 10 gigs, which is significantly higher. But now we have a short range. We're still at the short range. So why is it an X instead of a W? Okay, let's go back down. Here's what each suffix means. Other suffixes. We have LRM, long range multi-mode. ER, extended range single mode. Jesus Christ, single mode can already go crazy far in its ranges. Okay. ZR, Jesus, extended reach single mode. Whoa. What's the difference between these two mothers? That doesn't make it... Like, it's not me, right? Like, this is straight up just like a bunch of gibberish. BX, bidirectional single mode. Okay. Here's a summary of most common suffixes. SX. Okay. I'm glad that I have this all right here. Okay, SX is multi-mode. And that stands for short wavelength. SX. So is that mean SX is always going to be 100 base? Well, no, up here it said 1,000. Is SX fiber always 1,000 base? No, SX fiber isn't exclusively tied to 100 base gigabit Ethernet speeds. While 1,000 SX is the most common application, the SX and fiber optic terminology refers to the use of short wavelength optics. Buddy, short wavelength optics. So its core size its core size tells you which of these standards it's going to be. Well, that doesn't make any sense, because if that was the case, then why is this ER, extended reach single mode fiber, 1550 nanometers, and this is ZR, extended single mode fiber, 1550? See here. 1,000 base is a gigabit Ethernet standard utilized in short wavelength forms. What does the Z mean again? Okay. And multi-mode fiber to achieve data rates of 1 gigabyte per second. This is the most common of association of SX fiber. Other standards of SX variants, other fast Ethernet standards also exist that leverage short wavelength technology over multi-mode fiber, such as 100 base SX. However, these are less common in modern networks compared to 1,000 base SX. It is also important to note that the 100 base SX is industry de facto standard. So even though it is not common, it's the standard. So everything's just naturally a standard above the standard, not formally standardized by the IEEE committee. It is also important to note that the 100 base SX is an industry de facto standard. I don't know what what do you mean de facto? Like it's just the factory standard? But yet the line above it said, however, these less common in modem networks. These are less common in modem networks compared to. Yeah, no. I read that right. Such as this. However, these are less common compared to the 1,000. So the 1,000 base SX is more common than the 100 base SX. That is so hard to say. In essence, SX indicates the type of fiber optic transceiver designed in short range transmission over multi-mode fiber using specific wavelength, while 1,000 SX is the most prevalent application. It's not only instance where SX. Okay, so does the SX prefix mean the core size of the fiber cable? No, God, bro, what is the answer? No, the SX prefix in fiber optic networking does not directly refer to the core size of the fiber cable. Instead, SX indicates a specific characteristics of the fiber optic transceiver and the type of fiber it's designed to work with. Short wavelength SX. So short wavelength SX standard for stands for short wavelength. These transceivers typically use 180 nanometer lasers. Multi-mode fiber SX. So sometimes when I'm doing this stuff, I feel like there's middlemen that don't need to be there. Like, why? I don't... I don't know. So then, what is the difference between... When comparing ER extended range and ZR zero God, man, why can't I read that? Dispersion, shifted range, also often used to mean extended range in the context of single mode fiber in 1550 nanometer wavelength. The primary difference lies in their transmission distance capabilities. Oh, it doesn't label the distance right here. And standardize. Use single mode fiber. So wavelength is the core. So is wavelength the core, and is the core what is talked about? So is the wavelength, that's one word, and is the core the size of the fiber glass in the center of the wire that is measured in nanometers? I swear to God, if it thinks I'm talking about New Mexico, I'm gonna be done. What is... God, dude. Okay, no, that's not quite right. Let's clarify the relationship between wavelength, core, and core size and fiber optics. Core. The core is the central part of the fiber optic cable, typically made of glass. Okay, that's what I said. Through which the light signal travels. It's the inner part of the fiber that guides the light. Makes total sense. Core size. This refers to the diameter of the core. Yeah, okay, that's exactly what I said. It's a physical diameter, usually measured in micrometers. For example, single mode fiber typically has a core diameter of 9 micrometers. So then what the hell is in M? I thought that was nanometers. Okay. While multi-mode fiber core diameters are usually 50 micrometers, whatever. Wavelength. Wavelength is a property of the light itself. Okay. The signal travels through the core. Its distance between two... Okay, hold on. The distance between... Okay, hold on.
Wavelength. Wavelength is a property of the light itself, the signal traveling through the core. It's the distance between two consecutive peaks of the light wave and is measured in nanometers nm. Common wavelengths used in fiber optics are 850 nanometers and 1,300 nanometers for multimode fiber, and 1,310 nanometers and 1,550 nanometers for single-mode fiber.
Okay, so we're dealing with 3 different things here. We're dealing with the core. The core is the actual fiber, the actual glass that is inside the cable. That's the core. Core size is the diameter of what that thing is. And that's measured by micrometers. Okay? Then we have the wavelength. The wavelength measures the light itself. The single travel through that travels through the core. The wavelength is the distance between the consecutive peaks of the light wave and is measured in nanometers. Common wavelengths. Okay, but what does it mean by the two consecutive peaks of light wave? Okay, so here's its relationship.
While they are different things, they are closely related in how fiber optics work. Core size influences how light propagates. Single-mode fibers have very small core diameters around 9 which allows only one mode path of light to travel, reducing signal reflections and minimizing attenuation for long distances. Multimode fibers have larger core diameters. For example, 50 or 62.5,
Wow, that's a significant
which
difference.
allows multiple modes of light to travel simultaneously, making them suitable for shorter distances. Due to increased attenuation over long distances, wavelength affects attenuation. Different wavelengths have different attenuation characteristics in fiber optic cables. For example, scattering, where light bounces off atoms in the glass, is higher at shorter wavelengths and decreases as wavelength increases. In essence, the core size of the fiber cable determines how many modes of light can travel through it, and the wavelength of the light affects the amount of signal loss or attenuation experienced during transmission. They work together to determine the overall performance and capabilities of the fiber optic cable.
Okay. Okay, talk to me. What do we got?
Think of a wave, like a ripple in a pond, or a wave on the ocean. It has a repeating pattern of highs and lows, peaks or crests. These are the highest points of the wave. Troughs.
Okay.
These are the lowest points of the wave. The phrase two consecutive peaks of the light wave refers to the highest point of one wave cycle and the highest point of the next wave cycle. Visualization. Consider a sine wave, which often represents a wave's movement. The distance between the highest point of one hump and the highest point of the subsequent hump is the wavelength. Therefore, two consecutive peaks are two adjacent crests or troughs of the wave. The distance between them is the wavelength.
Whoa. I just had a huge flashback to high school calculus. Oh my god. That was like a dormant memory of this exact lesson and physics. I feel like I just awoke something inside my brain. Like I just grabbed a box deep within my subconscious, pulled it, and now like some things like kind of fell and there's like dust everywhere, and it's like, oh yeah, hey look, do you remember this toy you used to play with when you were 2? Like that just kind of shook me. Okay, I don't know if people still say shook anymore. Okay, so this is the wavelength. Okay, let's go back a little bit. Now that we're armed with a little bit of knowledge. 1000 base SX, that stands for short wavelength. My problem is that it's yet to give me all of these suffixes and all of its variations when telling me if it's multimode or it's wavelength. So I want you to give me all of the fiber standards and tell me its base, what it means. So like SR means short, no, sorry, SX. Short wavelength to tell me its speed and its wave length and its core size. I forgot how to spell size. My brain is legitimately melting right now. And if it is multi-mode or single mode. Example, because I don't want to jack around with this. I want this SX short wavelength multi-mode 10 gigs. This is wavelength gigabytes per second. What was the other one I wanted? Okay. This is gonna help. This is definitely 100% overkill, but I'm tired of getting these questions wrong. I'm so over it. Like, I have to know what this shit is. Yeah, give me all of them. Give me all of them. Every single one. Okay? No, this list is not exhaustive, and there are many other fiber standards not included here. Additionally, the distance listed are approximate and can vary depending on application and installation. I wonder if Bethany will bring me food. I'm hungry. We're about to read through all this, and we're going to break it down. Okay. Perfect. So SX, this means short wavelength. I don't know why X, like, okay. Why is it called SX for short wavelength and not SW? That's a very good question, and that often comes up in the context of fiber technology. While SW might seem like the more intuitive abbreviation for short wavelength, the use of SX likely stems from a combination of historical factors and desires for clear, unabridged naming within the IEEE Ethernet standards. Here's a breakdown of likely what it is. Okay, give me the bullcrap answer.
Avoidance of ambiguity. The term shortwave SW has a long-standing history in radio communication, referring to a specific range of radio frequencies and wavelengths. To avoid confusion with this existing and well-established terminology, a different abbreviation was likely chosen for fiber optics. Establishment of a naming convention, the IEEE Institute of Electrical and Electronics Engineers, which defines Ethernet standards, likely adopted SX as part of a structured naming convention for fiber optic standards. This allows for consistent differentiation between various fiber types and wavelengths. For example, LX denotes long wavelength, typically using 1310 nanometers lasers and single-mode fiber. Industry custom. Once a term like SX is adopted within an industry standard, it becomes widely recognized and used out of custom, even if the initial reasoning behind the specific letter choice isn't immediately obvious.
In essence, the choice of SX and SW in fiber optic standards for short wavelength is likely a deliberate effort to avoid confusion with existing terminology. I can appreciate that in other fields and to establish a clear and consistent naming convention within a realm of fiber optic. Okay, I can appreciate that because there's a lot of acronyms out there that are the same but they mean different crap. Okay, that makes me feel a little bit better on the inside. So base 10,000 or 1000 base SX is 10 gigabytes. That means that this is short wavelength, speed 1 gigabyte to 10 gigabytes. The wavelength is 850. Core size is big, so this is multi-mode, and it's easy to tell that it's big because like the single mode is like a single digit. Distance is up to 500 meters, 550 meters. LX stands for long wavelength, which means the wavelength is the distance between each hump in the wavelength. Okay, I understand that. We have 1000 base to 10 gigabyte base. Just like how we did SX. So the difference with this is that this is single mode because the core size is so small and it can go for so long. I may not understand or have a concept of what a meter is because I'm America. But I do understand that meters are smaller than kilometers or kilometers. Is that how you say it? Is kilometers and kilometers, is that the same thing? Is it just pronounced a different way? Is that... No?
5 kilometers.
Yes. Okay. I don't think anyone says kilometers. I think that's stupid. I don't know. I don't do this. I measure things in bushels and pecks. You know what I'm... Jesus. Okay. Distance up to 5 kilometers. I do know that that's of roughly 3 miles. I do have reference for that. Oh, my girl's calling me. I bet she's going to get me food. Yeah, she's bringing me food. Okay, so SR stands for short reach. So SR has a base of 10 gigabytes, 40 gigabytes, 100 gigabytes. Okay, short reach is the wavelength is significantly shorter. So short reach is the distance between the wavelength, right? So the difference between the the SX and was it SR is the length of what? The length of the wave length. And the SR is short reach, meaning the wavelength is shorter. I swear to God. No! Oh my God! Okay, no, the difference between SX and SR is not primarily the wavelength. SX and SR typically use the same short wavelength. Oh crap, I was looking at LX. So then what the hell's the difference? The distance?
No. The difference between SX and SNR is not primarily the wavelength. Both SX and SR typically use the same short wavelength of 850 nanometers. Here's the breakdown of what each term signifies. SX, short wavelength. This term is used in the context of Gigabit Ethernet 1000 base SX, and specifically refers to using a short wavelength laser, typically 850 nanometers over multimode fiber. The SX stands for short reach over multimode fiber, according to OptCore. The reach for 1000 base SX varies depending on the type of multimode fiber, but it's typically in the range of a few hundred meters, for example, up to 550 meters on OM2 fiber.SR, short range. This term is used in the context of 10 gigabit Ethernet 10G base SR, and also signifies a short reach over multimode fiber using the 850 nanometers wavelength. For example, 10G base SR transceivers can link up to 300 meters on multimode fiber. It is the most common and cheapest 10GB optical module available, says GLSN.
So then what the hell is the difference? Like, am I
Key
crazy?
differences. Speed. SX is for gigabit Ethernet 1 gigabits per second, while SR is for 10 gigabit Ethernet 10 gigabits per second. Application.
Now hold on a second. SX can also go to 10 gigabit Ethernet. But I clocks out at 10. Where SR can go up to 40 and even 100. Okay.
SX is often found in local area networks, LANs, and access networks, while SR is commonly used in data centers and high-speed connections. Between switches and routers, says Walson. Transceiver type. 1000 base SX typically uses SFP transceivers, while 10G base SR uses SFP plus transceivers. While both use short wavelengths and are designed for shorter distances over multimode fiber, it's crucial to remember that they are associated with different Ethernet speeds and their corresponding standards, 1000 base for SX and 10G base for SR. Monitor.
Okay, so SX is, its standard is 1000 base, but it can go up to 10 gigabytes. This base, its standard is 10 gigabytes, but it can go up to 100 gigabytes. That's the difference. The difference between the short range and the long wave is speed. Okay, so let's double check that and have it tell me no. So the difference between fiber standards that are short wavelength and short reach is the speed. Example, 1 gigabytes per second versus 10 gigabytes per second. Whoa. I misspelled standard. That's okay. I swear to God if it says no. You've hit a critical point. We've distinguished between fiber optic standards like SX and SR that both utilize all the same. So basically they're exactly the same, except one can go faster. I feel like it just was never explained well. Am I wrong? Am I crazy? Am I stupid? I mean, I get it. I'm a boomer. But now this makes sense because it has the word long in it. And since it's long and it's 9 microns, it's single mode. So it's in a completely different category than the two that we're talking about. Got it. So LR is long range, single mode, and is the difference between... Why didn't they group them? They should have grouped them. So LX can go... So it's a long distance, and it's wavelength. And the difference between the wavelength and the reach should be the speed. Yes, here it is. So LX can only go up to 1 gigabyte or 10 gigabytes, while the LR can go to 10 gigabytes, 40 gigabytes, 100 gigabytes. And it is single mode. It's all starting to come together. It's all starting to come together. I'm cautiously optimistic. Okay? This goes up to 5 kilometers. This goes up to 10 kilometers. Jesus Christ. That's far. That's like over 6 miles. That's crazy. That's crazy. Okay. Now we have LMR, which wasn't a part of our thing, so we're not going to get too hung up on it. Long reach multi-mode. So it goes up to 10 gigabytes because we have reach, even though reach should normally go higher, but since it's long range, it can go up to 200 meters. And it's multi-mode, which means that it's normally going to be shorter. So how does long reach multi-mode compare to the other multi-mode, which would be SR? Okay, so why would I use... Oh, because the wavelengths are further apart. I don't know what's better. Wavelengths that are shorter or further apart. What is better for fiber? Bigger wavelengths or smaller? Choosing the better wavelength for fiber optics depends entirely on the specific application and its requirement, especially in terms of distance and cost. There isn't one wavelength that is universally superior. Here's a breakdown. Shorter wavelengths, primary use, suited for long distance transmission over multi-mode. Okay, so shorter wavelengths need short distances over multi-mode. Attenuation, experience higher attenuation, signal loss, cost generally less expensive. That makes sense. Okay, bandwidth can offer good bandwidth. Okay, long length wavelengths primarily ideal for longer transmission. Distances are primarily used for single mode fiber. Experience significantly lower attenuation. Okay, because it's only dealing with one. That makes sense. So which is better? Short distances is going to be a shorter wavelength. Long distances is going to be dealing with a longer wavelength. Okay, this all makes sense. ER, ZR. Okay, distance is the difference is the distance. VX is bidirectional. Extended reach. 80 kilometers. Dang. That's crazy far. Okay, I feel like we've gone down this road really, really crazy. Let's read the question again.
A network installer is building a long-distance link. The nodes are approximately 5 kilometers apart. What type of fiber link should the installer build for this link?
Okay. 5 kilometers. So we need something that's going to go long. So that's why it is the long wavelength. Gigabyte long wavelength. 10 gigabyte SR. That is short range. That has a $40 meters. Nowhere close to 5K. 5K. 10K. 40K. 80K. 10K, 40K, 80K. Okay, so what I just learned is that anything that's going to be a kilometer has got to be in single mode. Okay, anything that's bigger, anything that's going to hit at least a kilometer has got to be a kilometer. Which means that, is FX even part of this? Okay, let's see what this has to say.
The 1000 base LX is a gigabit Ethernet standard and supports 1 Gbps and a distance of 5 kilometers using single-mode fiber. Installers often use the 100 base FX fast Ethernet fiber standard for wiring backbones. It uses multi-mode fiber for speeds of up to 100 Mbps for a distance of up to 2 kilometers.
2 kilometers right there, kilometer X. Okay.
The 100 base SX is a fast Ethernet fiber standard that supports lengths up to 300 meters and speeds up to 100 Mbps.
Okay, so no, it doesn't have this. Is FX, is that multi-mode or single mode? I bet you anything that it's multi-mode. Is 100 base FX multi-mode? If this is not multi-mode, then I'm gonna cry. I'm gonna fully break. Yes. FX is designed typically used as multi-mode standards, wavelength distance. Okay, I think I'm starting to understand fiber significantly much better. Okay, the 100 base SX. So basically, I just gotta know which ones are multi-mode and which one are single mode. That's what it comes down to. Because okay, and I'm starting to understand these are just standards. There's different types of fibers, multi-mode and single mode. So SX is multi-mode. SR is also multi-mode. The only one that's going to be single mode is going to be LX, because LX means long distance. Long reach. Multi-mode, yes. LX, got it. Multi-mode, yes. Again with the long, single mode. Multi-mode, long reach multi-mode. So that one's a special case, but it literally says it in its name. Single mode is extended, so we have an extended. So it may not say L, but it has the word extended in there. Not to be confused with this one, but it also has multi-mode in it as well. Okay, single mode, we have extended. Wow, that is crazy. Okay, bidirectional is single mode. We have again extended. Again, we have extended. So anything that is L or extended is single mode. Anything that is short or fast is multi-mode. Anything that's multi-mode is less than a kilometer. Anything that is single mode is at least a kilometer or above, typically starting at the 5K range. So let's read the question again. I know I've spent way too long on this question, but I always get it wrong.
A network installer is building a long distance link. The nodes are approximately 5 kilometers apart.
And right there, long distance link, long waveform, approximately 5 kilometers. What type of fiber link should the installer build for this link? He needs LX because that's in single mode. That can go up to the distance of 5 kilometers. SX, RX is like 500 meters. FX, I don't know what it is, but I know that it's not a kilometer. Mother. Allows fiber distance up to 2 kilometers in full duplex. This just broke my entire study strategy. My entire memory base. This just broke all of it. Wavelength and distance. It commonly operates at 1310 nanometer wavelength, which when compared to the multi-mode fiber allows for distance up to. Wait, so does the wavelength determine whether it's single or multi? That shouldn't be a thing. Because this wavelength is... No, it's the core. The core size is what determines whether or not it is single mode or multi-mode. So what is the core size of FX? Because I don't think it told me. And 2 core sizes. Multi-mode fiber, which commonly comes in 2 core sizes. 6. Okay, so that's why it's multi-mode. It's probably one of the... so far, I'm sure that there's tons of other standards, but this is the only multi-mode standard that can go over a kilometer. Every other one is below a kilometer. And I don't think that it goes above 550. And that even that's like stretching. Okay. Allowing flexibility in network setup, says Cisco. Okay. Wow, I spent so long on that I have to log in again. Crazy. I did spend a really long time on that, but I understand it so much better. What are we on? We're number 5. I think we're on number 5. Yes. Yes. Okay, let's go to the next one. Oh, I got food here. I will be right back. Okay. I'm back. And I have food of the gods. Super excited about it. I'm starving. I'm gonna close my door. Yeah? Yeah, what's up? I have to go help with the TV. We just bought a TV. Give me a second.
Which of the following 802.11 standards will provide the fastest wireless network throughput and work in the 5 GHz band only? What type of connector should the engineer install to get the requested throughput of 30 Gbps or more? Enhanced Quad Small Form Factor Pluggable QSFP+ supports 40 GBE by provisioning 4 times 10 gigabits per second links. Enhanced Form Factor Pluggable SFP+ is an updated specification to support 10 GBE, but still uses the LC form factor. Dense wavelength division multiplexing DWDM provisions greater numbers of channels, 20, 40, 80, or 160. This means that there is much less spacing between each channel and requires more precise and expensive lasers. Coarse wavelength division multiplexing CWDM supports up to 16 wavelengths and is typically used to deploy 4 or 8 bidirectional channels over a single fiber strand. I'm studying for the SFP, Small Form Factor Pluggable. SFP is a type of transceiver module that is used in networking equipment to convert electrical signals to optical signals and vice versa. SFP modules are designed to support speeds of up to 1 Gbps and are typically used in fast Ethernet and gigabit Ethernet applications. SFP Plus, Small Form Factor Pluggable Plus. SFP Plus is an enhanced version of the SFP module that supports speeds of up to 10 gigabits per second. SFP Plus modules are designed to support 10 GBE 10 gigabit Ethernet applications and are commonly used in data centers and high-speed networking environments. QSFP Plus Quad Small Form Factor Pluggable Plus. QSFP Plus is a type of transceiver module that is designed to support speeds of up to 40 gigabits per second. QSFP Plus modules are typically used in 40 GBE 40 gigabit Ethernet applications and are commonly used in data centers and high-speed networking environments. QSFP Plus modules have 4 channels, each capable of transmitting data at speeds of up to 10 gigabits per second. Key differences: speed, SFP up to 1 gigabits per second, SFP Plus up to 10 gigabits per second, QSFP Plus up to 40 gigabits per second, number of channels, SFP, 1 channel, SFP plus 1 channel, QSFP plus 4 channels application, SFP Fast Ethernet, Gigabit Ethernet, SFP plus 10 GBE, QSFP plus 40 GBE. Real-world example. A data center needs to upgrade its network infrastructure to support 40 GBE speeds. The network administrator decides to use QSFP plus modules in the data center's switches and routers to support the higher speeds. The QSFP plus modules are used to connect the switches and routers to the data center's servers and storage systems, providing a high-speed and reliable connection. An engineer has installed a new router but is not connected to the core network yet. What type of connector should the engineer install to get the requested throughput of 30 Gbps or more? A technician is building a new network link between a switch and a router. Switch only has Ethernet ports, while the router only has fiber ports. What could the technician utilize to connect these two devices? A network installer is building a long-distance link. The nodes are approximately 5 kilometers apart. What type of fiber link should the installer build for this link? An engineer has installed a new router but is not connected to the core network yet. What type of connector should the engineer install to get the requested throughput of 30 Gbps or more? The T11 ANSI standard can be a particularly expensive way to connect a storage area network SAN, and involves 3 main types of components: the initiator, the target, and a director. What is the name of the standard described? A technician finishes running fiber optic cable across a large building to expand the internal network. The fiber connects to equipment in a rack with extremely limited space for a connector. Considering the situation and the types of available fiber connectors, which of the following will accomplish connectivity? The same hub has host A1 and host B1 connected. host A1 sends a request to communicate with host C2. Host B1 is communicating with host C3. There is a delay in communications between hosts A1 and C2 until the media is clear. Which Ethernet protocol is providing this function? An IT engineer chooses to use a fiber cable implementation that uses light-emitting diode LED technology rather than one that uses lasers. Considering the optic technology in use, what is the engineer implementing?
Oh, buddy, I didn't realize that my mic was muted that entire time. Man. That makes me so sad. That makes me so sad. Okay. Whatever. Was the engineer implementing duplex, multi-mode, bidirectional, single mode? I'm gonna say single mode because duplex is multi, multi-mode is multi, bidirectional is this is the only one that's different. Okay, maybe that was the throwaway. All right, here we go.
Which of the following 802.11 standards will provide the fastest wireless network throughput and work in the 5 GHz band only?
I apologize for having my mic off. I thought it was on. That's my fault. Okay, 802.11g is legacy. 802.11b is legacy. N is 5 and 2.4, but AC is just 5.
The T11 ANSI standard can be a particularly expensive way to connect a storage area network SAN and involves 3 main types of components: the initiator, the target, and a director. What is the name of the standard described? The fiber channel connects storage area networks using 3 main types of components: the initiator, the target, and the fiber channel switch. The initiator is the client device of the SAN. The target is the network port for a storage device. The fiber channel switch, sometimes referred to as a director, provides the connections between the initiator and the target.
The fiber channel connects storage areas networks using 3 main types of components. The interior is the client device of the SAM. The target is the network port for the storage device. The fiber channel switch, sometimes refers to as directory, provides the connection between. Okay. I'm just trying to make that make sense with how this has 4 channels. Actually, I need to know. Appears. The fiber channel sometimes director. The application layer of that applies business is a part of the infrastructure of the software defined networking. It applies in business logic and decisions and how to prioritize traffic where there's this. I want to know what this is.
Internet Small Computer Systems Interface ISCSI does not require a fiber channel switch.
Perfect. That tells me exactly what that is. Son of a gun. I want to know what it is, not just that it doesn't use a fiber channel. All right.
Internet Small Computer Systems Interface ISCSI. ISCSI is a protocol used for sending and receiving block-level data over the internet. It is a type of Storage Area Network (SAN) protocol that allows devices to communicate with each other over a network, using TCP/IP as the transport protocol. How it works. ISCSI works by encapsulating SCSI small computer system interface commands and data into TCP/IP packets, which are then transmitted over the internet. This allows devices to access and manage storage devices remotely, as if they were locally connected. Key features.
Okay, that makes total sense. All right, let's keep going.
A local connector, LC, is a small form factor version of the SC push-pull fiber optic connector.
Damn it.
It is available in simplex and duplex versions. SFP Plus use the LC form factor but run at speeds of 10 GB. A subscriber connector, SC, is a push-pull connector used with fiber optic cabling.
Can I get a picture of this? Okay. That makes sense. Okay. So then what does the other one look like? So this is supposed to be bigger than this? I feel like this is bigger. Oh, here it is broken down. Okay. Look at them all. Oh my god, dude, there's so much. DX, 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 SX, SX, MSX. I don't know what DX is. Uniboot, angle. Man, it's crazy. Okay. All I need to know is that the local connector is a small form factor of the SC.
An IT engineer chooses to use a fiber cable implementation that uses light-emitting diode LED technology rather than one that uses lasers. Considering the optic technology in use, what is the engineer implementing?
Well, I knew it couldn't be duplex because it's optic. Bidirectional could have been, but we haven't really talked much about that. What I need to know is the difference between these two things.
Multi-mode fiber is inexpensive to deploy compared to single-mode fiber. As such, it does not support long distances as single-mode. Multi-mode uses light-emitting diode LED technology. Single-mode cables support data rates up to 10 Gbps or better and cable runs of many kilometers, depending on the quality of the cable and optics.
Wow. Duplex is a configuration. Full duplex refers to communication configuration types. Okay, so maybe duplex isn't just through copper cables. Duplex can happen through all the other ones as well, I guess. I don't know. That's another good question.
The T11 ANSI standard can be a particularly expensive way to connect a storage area network SAN and involves three main types of components: the initiator, the target, and a director. What is the name of the standard described?
Fiber channel.
An engineer has installed a new router but is not connected to the core network yet. What type of connector should the engineer install to get the requested throughput of 30 Gbps or more?
QSFP+. Spent a long time talking about that.
An organization's data center has a raised floor that allows all cables from the servers to run under the floor to the switches. What kind of cabling is the data center most likely using?
Plinium.
A network installer is building a long-distance link. The nodes are approximately 5 kilometers apart. What type of fiber link should the installer build for this link?
We spent the majority of this stream talking about this shit. It is long waveform.
An IT engineer considers optical mode OM1 or OM2 cables for a project. The project requires cables that are rated for applications up to 1 Gbps and use LED transmitters. Of the following choices, which type of cable does the engineer select to use?
1 gigabyte per second and LED transmitters is a sign of multi-mode.
Network equipment in a rack system has limited in front-facing space with the door closed. A technician uses small form factor connectors to connect a fiber cable. Which of the following connector types is the technician using?
The LC. LC is a small form factor of the subscriber connection, I think is what it's called. Yeah.
Which of the following 800 and 2.11 standards will provide the fastest wireless network throughput and work in the 5 GHz band only?
It's going to be AC. That's legacy, and that is 2.4 and 5.
An IT engineer chooses to use a fiber cable implementation that uses light-emitting diode LED technology rather than one that uses lasers. Considering the optic technology in use, what is the engineer implementing?
Multi-mode.
The T11 ANSI standard can be a particularly expensive way to connect a storage area network SAN and involves three main types of components: the initiator, the target, and a director. What is the name of the standard described?
The initiator, target, and director means that it's a fiber channel, or that it's the fiber channel.
A technician finishes running fiber optic cable across a large building to expand the internal network. The fiber connects to equipment in a rack with extremely limited space for a connector. Considering the situation and the types of available fiber connectors, which of the following will accomplish connectivity?
The LC. LC is the small form factor of it. That was it for 5. Six.
A new office building has ports along the walls in each room, where computers, phones, and printers plug in to connect to workgroup switches. A network technician needs to explain to a junior network technician which tier of the network hierarchy the devices are connecting to. Which tier would the senior network technician be describing?
Ooh, the access edge. Yeah, it wouldn't be the backbone. The backbone would be like the things that are doing like the heavy lifting kind of stuff. Yeah. This is them jacking in. I'm jacking in.
Which deployment model might a travel organization use to handle higher utilization forecast during certain times of the year?
Ooh. Which deployment model might a travel organization use to handle higher utilization forecast during certain times of the year? I want to say hybrid, but I don't think that's right. hosted private. I'm going with it. Yeah, I don't know. We'll circle back
An
around.
IT engineer troubleshoots a small network. Previously, IT wired all nodes to a central closet. In the closet, the engineer discovers a hub. Which of the following represents the current physical topology and the current logical topology?
Bus. It's a star and it's a bus with the bus in the center, and that's like super old school. That's like mega bad.
Which of the following topologies is a network of two or more nodes that shares access to the network, but only one node can be active at any one time?
A ring. Wait, which of the following topologies is a network of two or more nodes, shares access to the network, but only one node is active in any one time? Oh, it's a bus. Because only one node can be active at a time.
You've implemented an ad hoc wireless network that doesn't employ a wireless access point. Every wireless network card can communicate directly with any other wireless network card on the network. Which type of physical network topology have you implemented in this network?
A mesh.
A real estate agent is uploading photos of the latest listing onto the corporate website. Once the agent uploads the photos, they pass through multiple servers undergoing quality checks and sorting to ensure that they appear in the most relevant searches. What term best describes the passing of data from server to server in this scenario?
Top. Ooh, it's either east or west or top of rack switching. Quality checks and sorting to ensure that they appear in the most. Okay, hold on. Listen to the corporate website. Once the agent uploads the photos, they pass through multiple servers undergoing quality checks and sorting to ensure that they appear in the most relevant searches. I'm gonna say east to west. Yeah. I don't remember what top of rack switching is.
In a spine and leaf topology, there are two layers, the spine and the leaf. What do the top-tier switches in the spine layer comprise, even though neither link to the other?
Backbone.
Cisco's design principles for a three-tiered hierarchy break large networks into smaller sections with different functions that are specific to each tier. Which layer of the three tiers provides fault-tolerant interconnections between different access blocks and is capable of using routing boundaries?
Distribution and aggregation layer.
Which deployment model might a travel organization use to handle higher utilization forecast during certain times of the year?
Was hybrid.
A hybrid cloud computing solution is ideal for a travel organization that runs a sales website for most of the year. Using a private cloud, but needs to break out the solution to a public cloud during times of much higher utilization. This model provides the flexibility to use both private and public clouds based on demand and requirements.
Wow.
What approach is used to communicate multi-protocol data between two routers?
Oh. What protocol is used to communicate multi-protocol data between two routers? It's one of these two, but I'm pretty sure it's generic routing encapsulation. Why do I think it's this? Why would it be transport layer?
Which deployment model might a travel organization use to handle higher utilization forecast during certain times of the year?
Hybrid. Talked about that. I'm getting tired, I'm not gonna lie.
An employee working from home uses a virtual private network, VPN, to access certain websites. To connect to the VPN, the employee needs to request access to a server. What kind of traffic is the employee's request from the machine to the server?
North to south. Ah, it was point-to-point protocol? What?
Point-to-point protocol PP is an encapsulation protocol that works at the data link layer, layer 2. PP has no security mechanisms, so must be used with other protocols to provision a secure tunnel. Generic routing encapsulation, GRE, works at layer 3. GRE packet can encapsulate an IP packet as its payload. GRE does not have any mechanisms for authenticating users or devices, and so is often used with other protocols in a VPN solution.
All right. This is good. Procedure operates with the network 3-level AOSI model, encrypt packets passing over the network. There's so many moving parts, man.
Which of the following methods is used to encapsulate IP packets for transmission over serial digital lines?
PPP.
Which deployment model might a travel organization use to handle higher utilization forecast during certain times of the year?
Hybrid. We've already had that multiple times now.
What approach is used to communicate multi-protocol data between two routers?
All right, 7. I'm not gonna lie, that one I feel like I know what's going on with that one.
What is the significance of the name localhost in the context of IP networking? It represents the highest priority host in a multicast group. It is associated with a numeric loopback address for internal testing. It is the default name for the primary network interface. It is a reserved domain name for future internet protocols.
Yeah, loopback. That's a puppy. 169, a puppy.
Two Windows hosts connected to a switch are contending to respond to ARP address resolution protocol queries. Only one of the hosts is receiving network traffic. What is the most likely cause of this issue?
There's duplicate IP addresses. Now, I don't understand what the difference is between, like, why is it a duplicate IP address and not expired? But it is duplicate IP address. Well, look at me being a clown. Duplicate MAC addresses? See, I guess. An expired IP address would not cause an ARP contingency between two hosts on the same network. An expired IP address would prevent a host from accessing the network, but it would not cause conflicts with the host in the network. I don't necessarily believe in that one, because if I have an expired IP address and I still have the IP address, and for whatever reason I just never got another one, the DHCP server is going to think that it has that IP address, and it's the mother, it's the god. So my little computer thinks it has, I don't know, 192.00.1, but it knows, but it doesn't, because it's not communicating back. So it's going to give it out to somebody else. So now there's two machines that have duplicate IP addresses that are now responding back to the same ARP request. The expired IP address is the cause. The duplicate IP address is the effect. Okay, so what is the actual question?
Two Windows hosts connected to a switch are contending to respond to ARP address resolution protocol queries. Only one of the hosts is receiving network traffic. What is the most likely cause of this issue?
I don't want to know why. It's going to tell me that it's an expired IP address. Let's look here.
Two Windows hosts, host A and host B, are connected to the same switch and have the same IP address, 192.168.1.100. When an ARP query is sent to the switch, it will only forward the query to one of the hosts, causing the other host to not receive network traffic. To resolve this issue, one of the hosts needs to be assigned a different IP address.
I guarantee you it's going to say it's expired.
A company has 725 hosts on the network that utilize public Internet Protocol IP addresses. In addition, it has 3 contiguous Class C addresses for the hosts. The company recently implemented classless interdomain routing CIDR to assist with the maintenance of their 3 networks. What benefit will CIDR provide for the company's network?
CIDR is the translation between DHCP and PAT. PAT assigns all of these private IP addresses ports. CIDR translates that so that way it can talk to the main public IP address. I believe that's correct. Let's see what our choices are.
CIDR will allow a network designer to allocate ranges of IP addresses to subnets that match the predicted need for numbers of subnets and hosts. CIDR will use bits normally assigned to the network ID to mask the complexity of the subnet and host address scheme. CIDR will provide translation between the private and public addresses. CIDR will provide groups of address ranges reserved for special use and are not publicly routable.
This one seems correct, but I don't think CIDR has anything to do with subnets. I'm gonna go with this one because that was my original thought. Okay.
A system administrator has installed a new client computer on the network. The computer is getting an IP address of
a puppy. Yeah, that's what that is.
The hosts on a company's network all use a public Internet Protocol IP address. The first octet in the IP range is 132.
Okay. 127, I believe, and above. No. I think it's 128 and above is B. And then 192 is C. So that means that this is B. Yes.
A Windows server cannot connect to the public network. After entering an IP config all command, you discover that the server has an IP address of 169.254.219.
The server has an puppy address.
A network administrator is setting up a 192.168.1.0 network using variable length subnet masking VLSM to support the sales and marketing department. The sales department has 120 computers, and the marketing department has 50 computers. Which of the following Internet Protocol IP address configurations will provide adequate support for the marketing department? Select 2.
Okay, gotta do math here. And I barely understand its math. See, I think this right here is the puppy, not the puppy. The this CMAT or whatever it was. Oh, that's the shorthand. Okay. Because when you put something into a subnet mask, you have to be careful because you could end up wasting a lot of IP addresses because of the way the math works out. So we want one that's gonna fit the sales department and one that's gonna fit the marketing department. So I'm gonna say Man, I cannot remember the math on this. Yeah, we're going to come back to it.
What allows a network designer to allocate ranges of Internet Protocol IP addresses to subnets that match the predicted need for the number of subnets and hosts per subnet?
SIDAR. SIDAR is what does it. I remember now, after reading that last question, SIDAR is the abbreviation of the subnet mask, which I think is also the port number. But don't quote me on that one, but it's definitely, that's like where you have the IP address, IPv4, and it's / something. That's SIDAR. Instead of saying the IP address and the subnet mask is 255.255.255.255. Man, give me the clown nose, dude. Honk honk.
Two Windows hosts connected to a switch are contending to respond to ARP address resolution protocol queries. Only one of the hosts is receiving network traffic. What is the most likely cause of this issue?
Duplicate MAC addresses.
A duplicate media access control MAC address causes both hosts to contend with each other when responding to address resolution protocol ARP queries. Then, communications could be split between them or reach only one of the hosts. If Windows detects a duplicate Internet Protocol IP address, it displays a warning and disables IP.
So tell me why it's not a duplicate MAC address.
While a duplicate MAC address can also cause issues, it is less likely to be the cause of this problem. MAC addresses are typically unique to each network interface, and most operating systems will not allow two interfaces with the same MAC address to exist on the same network.
So how can it be the duplicate MAC address? Okay.
Address scheme.
What?
CIDR will use bits normally assigned to the network ID to mask the complexity of the subnet and host address scheme. The company is using classless interdomain routing, CRDR. CIDR uses bits normally assigned to the network ID to mask the complexity of the subnet and host addressing scheme within the network. This allows CIDR to collapse the company's 3 routing entries into one single entry.
So I was right. Well, I wasn't right with this one. I was right when I remembered what SIDAR was. So it's not the translation, it's just an abbreviation. The complexity of the subnet mask. Okay. Alright, I'm tired, but we gotta learn this. Stupid AI, just, it's like, 4 seconds, that was long enough for me to decide. Oh yeah, that's what this is. Got it, cool, moving on, thank you. This, bro, I'm too tired for this, but we gotta do it. Oof, oof.
Explanation. To provide adequate support for the marketing department, we need to ensure that the subnet mask we choose will provide enough IP addresses for the 50 computers in the department. Let's calculate the number of IP addresses needed. Marketing department, 50 computers will add 2 to this number to account for the subnet address and the broadcast address. 50 plus 2 equal to 52 IP addresses needed.
Okay, we need 52 because you always add the one before it and the one at the very top for they're reserved for broadcast and something else. Gateway, I believe. Now let's calculate the IP address provided by each subnet and mask options. So 192.168.1.0/25. Subnet mask for that is going to be 255.255.258. The number of IP addresses is 228 2 to the 7th power. Dang. So that's 2 times 2 is 4. Times 2 is 8. Times... Where'd we get 7 from, by the way? Okay. 8, 16, 32, 64, 128. It's a lot. But that's going to be enough for those computers. Got it. This is more than enough IP addresses for them. Okay. The one that ends in 192, this is the same subnet as option 2, which provides 64. Wow, it was lazy. No, it wasn't. Here we go. I didn't see it. So why is this 128? That's 128. How is this 64? Oh, the number of IP addresses. It's telling me how we got it. The math behind it. To calculate the number of IP addresses provided by a subnet mask, we can use the following formula. Number of IP addresses equals 2 caret to 30 minus number of bits in the subnet mask. So that's what it is. 32 subtract. So 32 subtract 192 must be 64. Let's give it a little testy test. Whoopsie. One 192 subtract 32. Okay. That I did something wrong because that 192 subtract 32 is 160. So number of IP addresses is 2 caret key 32 minus number of bits in the subnet mask. Okay, let's try it this way. 32 minus 192. I'm not getting it. So I'm not understanding something. For example, for the subnet mask 128, that's /25. We can calculate the IP address numbers as following. Number of bits is 25. So I guess I don't know how to get this 25. They got it through this. I don't know how that works though. The number of IP addresses is 2 to the power of 32 minus 25 equals 2, 7. Dang it. Hello? You are. I'm doing pretty good. That's okay. I don't think that we're interested anymore. Things are just, Ooh, she changed her tune real fast when I told her no. Wow. It's because you're selling a timeshare, dude. Like, no, I don't want to go. Okay. Where was I? Okay. 32 minus 25. 32 minus 25 is not 2. Am I just tired? Let's see here. 32 minus 25 is 7. So why does it say equals 2? I'm gonna have to dedicate a whole stream to figuring out subnet masks. Let's continue. I want to finish this, and then we're gonna come back to it.
What allows a network designer to allocate ranges of Internet Protocol IP addresses to subnets that match the predicted need for the number of subnets and hosts per subnet?
Variable linked subnet masks. Here we go.
Two systems
We're gonna
receive
come back
split
to this.
communications from ARP address resolution protocol queries. What would cause this configuration issue to occur? Which of the following is an Internet Protocol IP address that is in the Class B private address range?
No. Yes. Yeah.
What allows a network designer to allocate ranges of Internet Protocol IP addresses to subnets that match the predicted need for the number of subnets and hosts per subnet?
It's viable linked subnet masks. Oh, I know what this one is. This was 192.24, 25? No. We'll come back to it.
A company has 725 hosts on their network that utilize public Internet Protocol IP addresses. In addition, they have 3 contiguous Class C addresses for the hosts. Instead of maintaining 3 routing tables, the company has 1 single entry. What of the following allows the company to consolidate their routing tables?
CIDR.
A network administrator is reviewing the company's network and surveying current network configurations. After examining a few hosts, the administrator notes that the general Internet Protocol IP scheme starts with the first. Octet at 10 and all are using a default mask of 255.0.0.0.0. Which of the following is true for this network? Select 2.
No, it was /24. 26, 192. I'm tired. I just want to get through this. I want to go lay down. It's a private IP address. Okay, that makes sense because of the thing. I think I'm burnt.
2 Windows hosts connected to a switch are contending to respond to ARP address resolution protocol queries. Only one of the hosts is receiving network traffic. What is the most likely cause of this issue?
Complexity. I try not to do this. This is me just because I've memorized the answers, not me going through it and thinking it through. You know what I'm saying?
What allows a network designer to allocate ranges of Internet Protocol IP addresses to subnets that match the predicted need for the number of subnets and hosts per subnet?
Was it 192, 26? I think it was. Okay. We're going to stop right there. We're going to come back at it again tomorrow at 8 a.m. and we're gonna really hit it hard, because there's a lot of interruptions today. Like, we didn't even get to reviewing the test. Like, that didn't even happen. So anyway, yeah, we'll figure that out later. Hopefully tomorrow we can get to it. Anyway, I'm super tired. I think doing all that fiber stuff really kind of burnt me, and then having to stop and restart, that kind of messed with things as well. But we'll come back at it again tomorrow at 8 a.m. If my capture card is working, we will do Donkey Kong Bonanza. We will do that tonight around 8 o'clock. So long as technology does what it's supposed to be doing. Okay, I'm out of here. Makala Checo.